Hello everybody, I'm going to go over the homework for graph isomorphisms. So the first one was number 38, and that was a graph, both graphs, so let me call this G and this is H. And both had 5 vertices, so that doesn't rule them out that they're not isomorphic. So as always, the best strategy is to start listing the adjacency list. So we have U1, U2, U3, U4, and U5. Now, before you do that, you could calculate, let me do that first perhaps, although, the degrees. It's quicker to do on the picture, because rather quicker to see, right? 1, 2, 3, so 3, and here is 1, 2, 3, 4, so 4, 1, 2, 1, 2, 3, 4, and 1, 2, 3. Okay, and here I'm going to do the 2, 2, 3, 1, 2, 3, yeah, 3, and 1, 2, 3, 4. Is that correct? Right. So from this already we see that there is a problem, because we have only one vertex of degree 4. Let me see, I have I copied the right graph, right? This is 38. No, I made a mistake. What did I do? No, okay, no, that's correct. 3, 3, 4, 4, 2, and this is 3, 2, 4. No, I forgot something. What did I do wrong? Ah, okay, sorry. There's something missing in the left-hand graph here. So let me do. Because I knew they had the same degrees. This was too simple. But the graph that I now had was already ruled out, because there was only one of degree 4 and the other one had 2 degree 4. But that is because I forgot to list one of those. So this is now figure 4, 1, 2, 3, 4, 3, and 2. So we have the same configuration. And therefore, that doesn't exclude that they're isomorphic. And that's why I need to go to the neighborhood list. So you could wait and first figure that out, because, of course, that the sooner you find a reason for them not to be isomorphic, the less work you have to do. But that's not the case. So let's look at the neighbors. U1 has neighbors U2, U4, and U5. U2 has neighbors U1, U3, I'm going to try to list them in order, although that's not necessary, U4 and U5. It gets a little bit small. See, that's why I don't like putting these in these subscripts, right? Because it almost becomes illegible. U3, so I have to be a little bit more careful with my note. U2 and U4. U4 has, well, there are 4, so they are all the other ones, so I don't really have to think about it. It's all them, right? Because there are only 4 left. And U5, it has U1, U2, and U4. And then the neighborhoods here, V1 has neighbors V3, V4, and V5. V2 has neighbors V3 and V5. V3 has all the other guys, because it has degree 4. V4 has neighbors V1, V3, and V5, and then V5 has again everybody else. So the degrees, just recalculating the degrees, which we did already, 3, 4, 2, 4, 3, and here the degrees are 3, 2, 4, 3, 4. Okay, so we cannot conclude anything from there. I'm going to put again a dividing line here that we don't get our thing messed up. So the next thing we need to do is the degrees of the neighbor. Remember, this is something that I wrote as degree of the neighbors. This was the neighbors, and now we got the degree of the neighbors. Let's see, U2 has degree 4, U4 has degree 4, and U5 has degree 3. All right. U1 has degree 3, U3 has degree 2, U4 has degree 4, and U5 has degree 3. Okay. U2 has degree 4, and U4 has degree 4. U4 has degree, no, the neighbors of U4. The neighbors of U4 are U1, which has degree 3, 4, 2, and 3. And finally, the neighbors of U5, U1 has degree 3, U2 has degree 4, and U4 has degree 4. Okay, now, do we get the same patterns on the other side? If that's not the case, then we are done. Otherwise, we have to start more and more thinking about there might be an isomorphism. So V3 has degree 4, V4 has degree 3, and V5 has degree 4. So I repeat, if in case you're not following what I'm doing, I look at the neighbors and calculate their degrees and write them here in the same order, but we know that this order is not important here. Like, and therefore, for instance, okay, 443 and 434 is for us the same. There are 2 of degree 4 and 1 of degree 3. That's why we interpret. Okay, V3 has degree 4, V5 has degree 4. Then these are all the other guys, so that is 3, 2, 3, and 4, right? Okay, now V1 has degree 3, V3 has degree 4, and V5 has degree 4. And finally, this is again everybody else, 3, 2, 4, and 3. And what we notice is that we get the same patterns. Okay? The patterns on the left are patterns on the right. And that tells us, at this point, more likely that there is going to be an isomorphism. Now, so far, this is not wasted work, because it will help us deciding how the isomorphism will be built. So now I'm thinking more about building an isomorphism. So this is G, and I'm going to, or at least from the vertices of G, I'm going to go to the vertices of H and call this sigma. Okay, it's an isomorphism, so it goes basically in both ways. But and then now I'm going to try to do as much as I can with certainty before I start making guesses. We know that at some point you have to make guesses because you don't know exactly what goes to what. But there are certain things that are uniquely matched here, because there's only 1 of degree 2 at both sides, so they have to be sent to each other. This means that U3 has to be sent to V2. These are the 2 of degree 2. So there is no question about that. Now, the neighbors of, so let me, it's visual to make this, okay, U3 goes to V2. So now we see that U2 and U4 must be mapped to V3 or V5. Now, that's always the case, because these are the 2 of degree 4 and there's not more choices. So, is there any way that at this point, there doesn't seem to be any other reason anymore that anything sure anymore? So I'm going to make a guess. Let's work with what we have already. So I'm going to guess that U2, that's one of the neighbors of U3, that one of the neighbors of degree 4 is going to be sent to one of those, and I'm going to just pick V3. I'm picking one. And often in situations like that, whichever you pick, it kind of works. I'm not saying always, but it's a good chance. However, so this was no guess, right? But once I've done this, let me use our color schemes that we see what goes to what. So I was sending U2 to V3. Okay. So, but this takes care of the other degree 4 guy. Right? Now I know that the other degree 4 on the left hand side, that's U4, has to go to the other guy in the left hand side, and the right hand side, that is V5. So that is now also fixed. So again, I'm going to indicate this with colors that I know what I've been doing. So 4 goes to 5. So remains these 2 of degree 3. And at the moment, I don't see really any reason that there would be a choice here. They all look very similar. There's so much symmetry that I cannot decide. And so again, I'm going to make a guess. So I'm guessing that U1 is going to be sent to, I know it has to be V1 or V4. You might pick V1, so to be a little bit showing you that everything goes, I'm going to go with V4. Now, once I do this, that takes care of U5. because now we know that U5 has to go to V1, right? Yes. Okay. And just sanity check, do I have all 5 different ones here and all 5 different ones here, because it has to be a bijection, a one-on-one correspondence, right? Yes, that's the case. Also, let's make the colors, not that we probably, I don't know whether we need it, but just, I like coloring. So U1, we send that to V4, and then finally, brown, U5 is sent to V1. Okay. So, what's the next step now that we have a proposed isomorphism? We have to calculate the incidence graphs. And so what I'm going to do is calculate the incidence, and now I can think a little bit about it. Either I take the incidence graph on the left, the usual one, and then see let's see, we make sure that we don't do anything wrong here, right? So if we calculate, let's say, the incidence graph of G, okay, and we calculate that in what I'm trying to say here, sorry. So let me write it up. So the incidence graph of G, just using the usual order, okay, let's do this, U1, U2, U3, U4, U5, okay. Yeah, I could have used, let's see whether I can make my paper checkered paper. Okay, I'm gonna use checkered paper. That's gonna be a little bit more, making it a little bit more legible. I'm doing. Okay, so U1, U2, U3, U4, and U5. This is not part of the matrix, but it is just for me to know what I'm filling in here. And then here, U1, U2, U3, U4, and U5. So let's make the adjacency matrix of this guy. So I'm going to make it a little bit smaller for now, that I can fill things in. Okay, so U1, well, we know that these are zeros because it's a simple graph, so there will be nothing, there will be no loops. Then is U1, U2. There is an edge here, so yes. Also U4, this is 4, sorry, and U5. Okay, so that's just a 0. For U2, everything is there, so we have 1, 1, 1. For U3, we have U2 and U4, and the other twos are not there. U4, we have all of them. I'm just looking at the adjacent list and copying this by putting ones if they are there and zeros if they're not there. And then U5, U1, U2, and U4, so a 0 here. Again, sanity check. Do we have a symmetric matrix? If I go around this diagonal, and it looks very symmetric, so I think I filled it in correctly. Okay. So what needs to be done now? Well, now we're going to calculate, we have to compare this one with the incidence matrix, the adjacency matrix of the right-hand side, but now not in the standard order, but in the order, the new order that is given by this isomorphism. In other words, U1 has been sent to V4, so I'm going to put V4 first, okay, and then U2 is V3, so then comes V3. So the order that I'm writing here, and that will be the same order here, comes from, what is U1? U1 goes to V4. Okay, what is V3? U1 goes to V4, U2 goes to V3. What U3 goes to V2, so this becomes V2. Where am I? U4 goes to V5, so this is V5, and then finally U5 goes to V1, so this is V1. So I repeat, I calculate the incidence matrix on this side using the original order of the vertices that I have. Here I calculate, and we're going to use now this information, not this, but this information, to calculate the incidence matrix, but not in the order that you would take because of the numbering, but in the order that comes from looking at what U1 goes to V4, U2 goes to V3, U3 goes to V2, etc. Okay? Understand that? Now, I have a freedom. I could have exchanged the roles here. I could have calculated the incidence matrix of H in the usual order, but then I have to calculate this one in the new order that comes from now looking everything in that direction. I'm not going to work that out, but just so you might have done that, and I'll do it perhaps in a different video. I'll do that, show you how that would work. Okay, so here we are, V1. Okay, and so finally, what we need to do now is check it. Well, first of all, we know that these are zeros, so I'm not going to worry about that too much. So what I do now, I look at this data and see what is V4. V4 is mapped to V1, V3, and V5. Okay, V1 is here, V5 is here, and V3 is there. And that this makes it a 0. And only now I'm going to compare. Let's compare here using yellow. Okay, is this the same as this? Yes. Keep going, because it has to go, all the rows have to be like that. V3. V3 has, now look, V3, right? This tells me I have to look at V3, so I have to look at V3. Now there's all ones everywhere, so 1, 1, 1, 1. Is this the same? Good to see, it's the same. All right, so V2, that's the next one on the list, the third one, the third row, and that is V3 and V5. That's where they're located. Okay, it's not the third and fifth spot, it's V3 where V3 and V5 are. So these are zeros. Okay, if this checks out, then we are halfway done, and normally then things are getting better and better. Now, it's not necessarily true, so we have to do one more. V5 is mapped, well, everything is a neighbor of V5, so we get ones everywhere, and now we are getting better and better because this matches this one. And why do I know I'm gonna be okay? Because it's a symmetric matrix, right? So there is no choice anymore for this has to be also the row, and this is already the row. So here I'm done, but just for the fun of it, V1 is V3, V4, and V5, V3, V4, and V5, and we see it matches, and so everything, oh, there's no, everything matches, and so we have an isomorphism. That's what you have to do. Okay, that was number 38. There was also number 40. I'm going to do it here because it's rather short, except that I have to draw it. But so I'm actually going to be a little bit lazy here, and let's let's make the adjacency list of. No, I'll draw it. I'll draw it. I don't want you to have to go to the book and then follow me. Okay, so we have U1, U2, U3, U6, U4, and U5. So U1, U2, U3, U4, U5, and U6. Okay, and we have this connection, this. You know what? I'm going to insert a space. Oh, let me go down here. Let me go down here and then do it over again, because otherwise it's going to get too messy. So number 40. Okay, I'm going to do it here. So U1, U2, we have a line there, is U6. U6 connects this, and U6 also connects this way. Then we have U3 that connects this way, and then we go down here to U4. Well, the position is not exactly the same, but we have mentioned this now several times, right? That's not essential. And then make sure that I have everything. I think I have everything now. That is G again, and then H is a little bit more easier to draw. So we have, well, these are edges. Sorry, that was too far. I shouldn't draw them separately. And then we have one across and one this way. Okay, and that was V1, V2, V3, V4, V5, and V6. Now, they have given names to the vertices, to the nodes, but if that's not the case, you can choose your own names, okay? And I would suggest use things that are, well, some people like indices. It's just harder to read and harder, and it's easier to make mistakes with them. So I rather prefer just letters in alphabetic order or not, or even not in alphabetic order, as long as they are all different, of course. Okay, so let's list the degrees. That's always something you can do right away. So this is 3, 1, 2, 3, 1, 2, 3, 2, 2, and 3. And this is 2, 1, 2, 3, 1, 2, 3, 2, 1, 2, 1, 2, 3, 4. Aha. So degrees do not match. And therefore it cannot be isomorphic. No isomorphism. Okay, that's a very easy way of dismissing it. Now it's too easy a way to dismiss it, so that's why I gave you one more extra problem where it gets a little bit more subtle. And also in the review video for the next quiz, I'll give some more subtle reasons why things are not isomorphic. But that's one. Of course, both have six vertices, so that's not a way to exclude it. But there is the degrees do not match. Okay. Also, therefore, there are 2 of degree 2 in the left and 1, 2, 3 in the degree on the right. Okay. So let's go to the example that I had then given, the last one. Notice that I don't have given names yet to them, so that's why I was saying you have to put names yourself. So this is, let's say, G and this is H. Okay. We can list the degrees. Let's do that. 3, 3. For degrees, you don't need names, right? So 3, 1, 2, 3, 4, 3, 2, 2, and 2. Okay, and here we have 3, 1, 1, 2, 3, 4, 3, 2, 2, 2, 3, and 3. Now, there are 4 of degree 3 in both, 3 of degree 2 in both, and 1 in degree 4. So the degrees match. So here we have the degrees match. You have to kind of assume that that's going to be probably the subtle part, right? Now, that was too easy to dismiss, the previous case. So what now? Well, now we need to make the incidence graphs, incidence list, I'm sorry. And for that I need names. So I'm going to name them A, B, C, D, E, F, G, H. I use this order, but you saw the book very often likes to go seems to be like going around the clock order, but really does better. Now I have to make sure that I use different names here, and you can, for instance, use capitals if you rather to distinguish them, or Greek letters, or I'm just going to go higher in the alphabet, so say P, Q, R. There's an R, sorry, that's how I write my R's. This is an S, there's a T, a U, a V, and a W. Okay, so let's make the A, B, C, D, E, F, G, H. You see, it gets already, the picture is rather compact, right? And once you have the picture, there's a lot of information there. I mean, just drawing this takes some time, and also unraveling it takes time, therefore. So these are the vertices, these are the vertices of G at least, these are the neighbors of A are C, D, and B. I'm not going to concern myself to write it in a proper order, that doesn't matter anyway. The neighbors of B are A, D, and E, A, D, and E. I just read them off like that. From C are A, D, and F. A, D, and F. Then the neighbors of D is A, C, A, B, and E. C, B, A, C, B, A, and E. Sorry, I don't want to rewrite it. Okay. The neighbors of E were B, D, and H. B, D, and H. Neighbors of F, C, and G. Those of G were F and H. And those of H were G and E. Okay, and just if you want another sanity check, do we have the same degrees as before so that we didn't forget anything? On the picture, it's less, the degrees you count normally correctly, but once you start listing neighbors, you might forget one. And it's always good to double check always. Also, do we have the right number of odd degree? Yes, we have an even number, so that works fine. And so this is, again, I have to divide this. I'm going to divide it this way. And so here the vertices are P, Q, R, S, T, U, V, and W. And then oops, I don't know what happened. and then the neighbors. The neighbors of P are Q, U, and R. Q, U, and R. Those of Q are P, S, T, and R. Okay. Those of R are Q, P, and W. Okay, W. The numbers of S are Q and T. Those of T are S and Q. Those of U, that's P, V, and W. Those of V are U and W. And then finally, those of W are U, V, and the guy up there, R. Okay, so again, degrees, does everything still match? Oh, I'm gonna run a bit out of paper here. Okay, I'm gonna have to move this whole thing, no problem. 3, 4, 3, 2, 2, 3, 2, 3. Okay, I get the same amount as I wanted. Okay, as I said, let me move this around a little bit. Cool, huh? I can do this way, a little bit more perhaps. Yes, okay. So, what we're looking for next is the degree of the neighbors. Okay, so let's go there. C has degree 3, D has degree 4, and B has degree 3. Again, I'm reading this, I'm looking at these neighbors, and then looking at each of their degrees, and I write that up. That's what I'm doing. A has degree 3, D has degree 4, and what is the next? E has degree 3. Okay. See, A has degree 3, D has degree 4, and where am I? F has degree 2. Okay. The neighbors of D. C has degree 3, B has degree 3, A has degree 3, and E has degree 3. Oh, they all have degree 3. Okay. The neighbors of E, that is B, D, and H. The neighbors of F, C, G. The neighbors of G, F, which has degree 2, and H also has degree 2. And then the neighbors of H, G has degree 2, and E has degree 3. Okay, that's the patterns I get. What am I getting here? So the degree of the neighborhood. The Q. So the neighbors of P. So I'm looking at this. I'm looking at this row now. I'm looking at these three guys and calculate the degrees. Read it from the table. Q has degree 4, U has degree 3, and R has degree 3. Okay. Q. The neighbors of Q are P, which has degree 3, S, which has degree 2, T, that has degree 2, and R, that has degree 3. Now, you keep going, but I know now that there is a problem. Because remember, there's only one of degree 4. So that any isomorphism has to send this guy to this guy. No excuse. No other way around. But the neighbors of D all have degree 3, 3, 3. That's the only one of degree 4. That's a different pattern than here. This pattern is not going to happen anymore because there's no of degree 4 anymore, right? So this pattern is different from this pattern. So let me indicate this with red. This pattern and this pattern. We know that D has to go to Q if there's an isomorphism, but the patterns don't match. Don't match. And there's no other possibility because D has to go to Q. And that's it. Therefore, so in other words, no isomorphism. So as I said, it gets trickier. Now notice that what I did here, and I found my counterexample, so I know I can stop. I did basically the same in the first problem, but I needed to go I never found anything not matching, so I worked out the whole thing. But that was also useful for then finally deciding how I make my isomorphism. If I just try blindly without looking at the information that I have, I'm never going to guess the isomorphism. Remember, there are 5 factorial, which is 120 possibilities here, if you want to think about that. So guessing just arbitrary, it's not going to work. Alright, so that's for the homeworks, and then on the review I will do also similar thing. There will be a quiz on this.